Okay, so let's go to CD. All right, so actually, let's open up the terminal here. And now I'm going to run the main class. So this is the rabbit hunt program, and this is the program we call Fox and Rabbit. So what this is that it is it's a simulation of sorts. Okay. So look, it might if you're running a Mac or a Linux piece or some Windows, it might show up blank initially until you press step. But this is the board, and it represents basically a field. It's bounded, meaning that basically this doesn't work like Pac-Man. It's not wrapped. It doesn't wrap around. Okay. This is instead what we're doing here is instead these are essentially walls, but these green blotches represent bushes. The red dot represents a fox, and the brown dot represents a rabbit. Okay, these bushes block line of sight and basically movement, but otherwise they are just not really that important. And the way this works, if we hit run, is that basically the fox's job is to hunt down the rabbit and eat it. If the fox hunts down the rabbit, like it just did, fox eats the rabbit after 16 turns, the fox wins, right? For the rabbit to win, it has to avoid the fox for 100 turns, okay? So as you can see, this is what you get. This is, if you download the code in the zip file, this program works. It works on, this is what you will get if you download and run the code and import it into your ID of choice, right? The fox will go and hunt down the rabbit. And it has this way of doing this, right? What it does is that if we look at step, we see that basically the fox looks for the rabbit, and then once it sees the rabbit, it will go in that direction. Right, so let's increase the speed. Once it saw the rabbit, it started heading towards it for the rabbit, if it could still see it. If it couldn't see the rabbit, it headed towards where it last saw the rabbit. Okay? And that's the very basics of how the fox moves. The foxes, if we're going to be generous, call it AI. It's not. It's just a bunch of if statements. Okay? So your assignment for this is to take this code and improve the rabbit. Get eaten less, essentially. So, right, the fox, we can open up it over here, and we can take a look at, and I'm just opening it up in the text editor because I don't need to bother with an IDE at the moment, right? A fox is an animal, meaning it has a bunch of stuff. It has a bunch of variables, which I'll go over. But this is how it figures out where it's going to move with the method called decide move. And it basically looks all around for the rabbit, and you'll go over this later, and I'll go over this also on Wednesday in more detail. And then if it's seen the rabbit, it goes towards the rabbit. Okay, so it's a bit complex. Notice that the rabbit, though, not very complex, right? The rabbit is an animal, right? Got that whole is a relationship there, the inheritance relationship. It's got a constructor, which we can just safely ignore. That's just because we don't call the constructor ever, right? Or rather, we as the programmer don't. The person who wrote this called it. So if you're wondering why the rabbit got caught all the time, it's because its strategy is kind of terrible. You can kind of parse it from what it reads over here. What does it do? It runs in a random direction. Yeah, it just chooses a direction at random, and runs in that direction. So essentially, statistically, that means it doesn't move anywhere. It kind of statistically stays in the same spot. If every direction is equally likely, then every direct move it takes is going to cancel out every other move, and it'll basically not wander far, and the fox will find it and eat it. Okay. Your strategy is your goal is to basically come up with a strategy that will work. How will you get graded on this? Yes?
Could you possibly make it more like the fox?
Yeah. Yeah. So.
Instead of random?
Yeah, that's your goal. You want to give it a strategy. So you are allowed to change. So there's one rule for what you are allowed to do, and one rule only. You are only allowed to modify rabbit. That is your only rule. You can call stuff from other classes if you have access to it, and I highly recommend you do that. I'll go over where you have access and what accesses you do have and where that's important. But let's just go over how you're graded on this, okay? Run that, compile it, run it, okay? So the grader is pretty simple. This is what determines your grade. The rabbit escapes 2 times out of 300 or 0%, and the grade is 0. Now you might assume that basically that your grade is this, right? If you escape 50% of the time, you get a 50. That's not true. The way you're going to be graded is through a square root curve. Specifically, your grade is the square root of the number of the percent of times you escape times 10. What that means is that if your rabbit escapes 25% of the time, okay, what is the square root of 25? It's 5 times 10. So if your strategy is only 25% effective, you'll get a 50 because it'll be square root of 25 times 10. If you escape 64% of the time, that's a B. That's an 80. Okay? If your rabbit escapes 81% of the time, that's a 90, right? Because the square root of 81 is 9 times 10. That's a 90. So this kind of curve, square root curve, it really boosts those lower grades a lot. So even a very simple strategy will kind of help boost your grade. So now so how do you know what to do? Well, first off, I suggest if you get completely stuck with no ideas, take a look at what the fox is doing and just kind of do the opposite, right? But let's look at but a rabbit is an animal, so let's take a look at what all that entails, okay? So this is unimportant, the model stuff. I'll get into that in a minute. What we care about is these method headers. Random, this is what it used to figure out what direction to go at random. Not really a great thing. So it has the look method, which that finds the first visible thing in a given direction. So given a direction, one of the cardinal directions, north, northeast, east, northwest, southeast, south and so on and so forth, given one of those 8 directions, right, on a grid, it returns an integer representing the first thing it sees. And those integers and those are basically constants that are stored in the model class. So given a direction, you can look in that direction and you can say, oh, there's a bush to the east. Won't tell you how far. Or an edge to the east. It won't tell you how far. Or there's the fox to the north. It won't tell you how far, though. To tell how far something is, given you have the distance. So given a direction, it'll give you the distance it is from your position. There's also a can move, which given a direction tells you whether or not you can move into that. That's kind of useful for detecting whether or not, whether or not there's if you're at an edge. Okay. So the model has a bunch of functions, and by the way, I've given you a nice big PDF that goes into detail about these things, right? And it's pretty big. Now, the reason this is called model is because this program was built using the model view controller paradigm, this is a GUI. You probably haven't interacted with GUIs before. That's okay. You don't really need to know anything because remember, if you've been remembering what I've been saying, all you're doing is modifying the rabbit class, you're modifying and specifically you can modify anything you need to here. You can add more variables, and I highly suggest you do. But in the decide move class, which is what determines how you move, there's nothing graphical involved here. So the model view controller paradigm says basically we have the model, and that represents like the internal state, the rules, how everything interacts, what all the actors are, and what they can do. Okay, the view is kind of what it says. It's that class, the view class, is responsible for drawing everything, right? This is all. So if you're curious about how the GUI works and how it displays everything and how it draws everything on there, then you can go to the you can go and look at the view class. It's completely unimportant. You can ignore it, right? It's not useful for your solutions. Same thing with the controller. So if viewing is for seeing things, models for representing the internal state, the controller, which is the third part of this paradigm, that's the buttons essentially. When we run the rabbit hunt class, when we run this class, and it comes up with this, the controller is this: me clicking on buttons and responding to the button clicks. So if you want to know how to do that, you can check that out, right? Okay. Reset, by the way, allows you to generate a new board. So also the board is completely randomized, right? So you can't just like map out the board and store it in the internal state. You can't just take one board and map it out and store it as in the rabbit as that's what the board looks like, because it's got to be able to survive on all sorts of boards. Okay. Rabbit Hunt just creates the model, the view, and the controller and starts the game. That's all it does. Right? Creates the field, creates the model, the view, the controller, and that's it. So let's take a look at model. It maintains the field, and it holds the fox and the rabbit in it. Again, I'm sorry. Again, we aren't going to be modifying anything. The only thing you're modifying is the rabbit. Right? It has the fox, the rabbit, it has their coordinates and stuff. Notice they're private, so you can't really mess with them from the rabbit class. And it's got a bunch of static variables in there, right? So rather than remember the directions and the foxes and stuff, and the bushes, they're all represented by integers. But remembering something is an integer is kind of tough, right? Or what integer is kind of tough. So you don't need to remember that 0 is north, right? Instead, just call model.n. So you can use all of these. So min direction, max direction, 0 through 7 to cycle through all the 8 directions. And then stay, 8, just represents you deciding not to move anywhere because sometimes that's your best move, right? And then there's integers to represent whether you found an integer, a fox, a rabbit, or a bush. And I'll just simply, in a second, I'll show you how that works, which I did not do in the previous class, but I've decided that's a better idea. So other than that, there's really nothing here that you're really going to call except for this method over here, the turn method, which allows you, given a direction and the number of 45 degrees you want to turn clockwise, it gives you a different direction. So say you pass in north and 4, the return direction will be south, right? Right, because 4 45-degree turns is 180 degrees, which is the opposite direction. Passing in north and 1 would give you northeast. Passing in north and 6 would give you west. Passing in west and 2 would give you north, right? And it handles the modular arithmetic for you. So this is useful, basically saying, hey, if there's a fox that way, I'm going to go that way, right? Or maybe that way or that way, but basically getting the opposite direction. So you don't have to calculate so this this gives you the opposite direction. You don't have to calculate what the opposite direction is. So how does this work in practice? Well, so rabbit is a animal. So just to remember, you can call stuff like this dot look, this dot look function, and pass it a direction to make it look. So let's tell the rabbit to look north, okay? So this dot look model.n, okay? That will make it look north. That will give me an integer. And now if I say, this returns what it sees. So if I get this, also my font is fun. You'll get used to it in a bit. Notice that basically it turned that double equals into a big double equals. It's because just some features of the font I'm using. Notice that when I do not equals, so if I do exclamation point equals, when they're next to each other, they combine into a big nice not equal sign. It's just something I do for readability. Okay. So not equal. So if the look is equal to model.fox, then we know that the fox is to the north, right? Although it doesn't make sense really to create 8 if statements. You'll probably want to do a for loop and something like that, right? So, but basically this is kind of the idea here. So so this is what you'll probably want to do in this first session and you'll have a lot more time next class, because this class we had to go over the syllabus and, tell you that, hey, you should bring a laptop and that kind of stuff. So, and also there'd be plenty of new people in the next class. For this class, I suggest basically learning how to get this importing the code into your IDE, remembering how to do that. Generally, the general steps for that are create a new project, okay, in either Eclipse, NetBeans, or IntelliJ. Select all the files that you've downloaded, right? Not the zip file, but unzip it, then select all the files. Then copy those files, and then paste them into the source folder, okay? And if you need help with that, I'll give you a refresher on how to do that. And that will bring all the files into the IDE of your choice, okay? Then don't necessarily come up with a strategy, like what kind of strategy you want to work towards, but your first strategy that you implement should probably be something terrible, just to confirm that that it's working. Like, this is a terrible strategy, by the way, which is if I see the fox, go in the opposite direction. That's the only decision it decides to make, right? That's a terrible strategy. You won't live long with that strategy, but you'll be able to see. And if you don't see the fox, stay put. But it's a strategy you can see that the rabbit will then be able to follow your commands, right? You can confirm that you have control. Is kind of the idea. All right. So I'll be around the class. So go ahead and get started. I'll be around the class to help everybody.